Hello, my name is Molly McGhee, and today I will be presenting results of research conducted at the University of Illinois in which we investigated the effects of feeding hybrid rye to weanling pigs. The experiments we have conducted with hybrid rye have been done in collaboration and with financial support of KWS Cereals, the plant breeding company behind the creation of hybrid rye. Rye can be used in the human food industry as a flour for baked products or as a substrate for whiskey distilling. Rye can also be fed to livestock, as I'll be discussing today. Hybrid rye is already commonly grown in Northern Europe, but has only been available to the North American market for less than a decade. Historically, rye was not fed to livestock in large amounts because of its reputation for reducing feed intake and being prone to ergot. But new hybrids of rye address some of these issues. KWS hybrid rye has mitigated the risk for ergot contamination, and today it is also common practice for feed mills to clean rye of any ergot sclerotia that has ended up in the grain after harvest. The production of hybrid rye in North America and Europe is also increasing because it's an attractive crop for farmers to add to a rotation. Hybrid rye has greater yield than conventional open pollinated rye, and it can also outyield barley and wheat when managed correctly. It is a very hardy crop that can tolerate environmental conditions like drought and cold temperatures that may destroy other crops. Over the last several years, our lab has conducted a series of experiments to determine the nutritional value of hybrid rye for growing pigs and compare that value to other cereal grains. Compared with corn, hybrid rye has about 150 fewer kilocalories per kilogram metabolizable energy on an as-is basis, and one of the primary reasons for this is because it has less starch. Hybrid rye consistently has about 55 to 56% starch, whereas corn has upwards of 60% starch. One thing that differentiates hybrid rye from other crops is its amount and composition of dietary fiber, though. Rye has approximately 16 to 18% total dietary fiber, and it is more fermentable than corn, barley, wheat, and sorghum. Corn, on the other hand, only has about 10% total dietary fiber. In terms of digestible amino acids, hybrid rye and corn are quite comparable. Hybrid rye has more total amino acids than corn, but the digestibility is reduced. For standardized ileal digestible lysine, hybrid rye contains 0.25% and corn contains 0.22%. Lastly, hybrid rye has more total phosphorus as well as greater digestibility of phosphorus without the inclusion of phytase. Therefore, as you can see here, the concentration of standardized total tract digestible phosphorus is greater in rye than in corn. Using the nutritional composition and digestibility values derived from previous experiments, we conducted a series of experiments to test the hypothesis that hybrid rye may replace corn without influencing the growth performance of pigs in various growth stages. In the experiments that I will discuss today, we hypothesized that the growth performance and incidence of diarrhea would not be changed when hybrid rye replaces corn in diets for weanling pigs. In each experiment, we used a three-phase feeding protocol. In Experiment 1, Phase 1 diets were fed from day 1 to day 7 of the experiment and had increasing inclusion rates of rye up to 12% and the highest inclusion rate diet. Phase 2 diets were fed from day 7 to 21 and contained 0, 5.3, 10.7, 16.0, or 21.4% hybrid rye. Lastly, Phase 3 diets were fed from day 21 to day 34 and contained 0, 15, 30, 45, or 60% hybrid rye. Pen was considered the experimental unit and there were 8 pens per treatment. Let's move on to the results now. In each of my slides, the bar graphs with colors ranging from yellow to dark orange represent the increasing amounts of hybrid rye in the diets. The legend on the right shows the replacement rate, and note this is not the inclusion rate, of corn for hybrid rye in Phase 3 as a reference. All variables were analyzed using linear and quadratic contrast statements to test for effects of including graded levels of hybrid rye in the diets. As you can see from this graph, body weights did not differ during the experiment, whether that was on day 1, 7, 21, or 34. Similarly, average daily gain did not differ in Phase 1, Phase 2, Phase 3, or overall. For average daily feed intake, we did begin to observe differences among treatments. In phase 1, there was no effect of hybrid rye inclusion on average daily feed intake, and the same was true for phase 2. In phase 3, however, a quadratic effect was observed for average daily feed intake, where the greatest inclusion of hybrid rye resulted in the greatest feed intake. Similarly, average daily feed intake was also quadratically increased with greater hybrid rye inclusion for the overall experimental period. This effect for average daily feed intake is likely due to the reduced metabolizable energy content of hybrid rye compared with corn. Thus, these pigs consumed greater amounts of feed to compensate for their total energy intake. With gain to feed, we observed no differences among treatments in phases 1 or 2, but a quadratic effect was observed in phase 3 and overall, where gain to feed was reduced with greater inclusion of hybrid rye. This makes sense because the pigs consume more feed but gain similar amounts of weight during the experiment. Phase 1 diarrhea incidence was reduced with greater hybrid rye inclusion, as you can see in the first cluster of bars on this graph. However, no effective treatment was observed for phase 2 or phase 3 diarrhea incidence. It is possible the fiber fraction of hybrid rye had a positive impact on the colon health of pigs, resulting in decreased diarrhea in the first phase. Finally, to wrap up experiment 1, we observed that on day 21 and day 34 of the experiment, blood urea nitrogen increased as the inclusion of hybrid rye in the diet increased. This indicates that pigs fed hybrid rye had more amino acid catabolism and less efficient utilization of dietary protein. In conclusion, the results of experiment 1 demonstrated that average daily gain was not influenced by hybrid rye inclusion in diets for nursery pigs, although gain to feed was reduced due to the reduced metabolizable energy content of hybrid rye. Furthermore, phase 1 diarrhea incidence was reduced with hybrid rye inclusion in the diet, and our overall hypothesis that weanling pig performance would not be compromised by inclusion of hybrid rye in their diets was supported. Based on these results, we predicted that greater inclusion rates of hybrid rye could be fed to nursery pigs without affecting growth. Therefore, we conducted a follow-up experiment to test the hypothesis that growth performance and diarrhea incidence would not be impacted by including greater amounts of hybrid rye at the expense of corn in diets for weanling pigs. Similar to experiment 1, we had 8 replicate pens per treatment, and pigs were fed in a 3-phase feeding program. From day 1 to 7, pigs were fed either 0, 8, 16, or 24% hybrid rye. In phase 2, those inclusion rates were increased to either 0, 16, 32, or 48% hybrid rye. Lastly, in phase 3, which was from day 21 to 35, pigs were fed either 0, 20, 40, or 60% hybrid rye. Like in experiment 1, even with greater inclusion rates of rye, there was no effect of diet on average pig body weight at any time point during the experiment. Average daily gain increased linearly in phase 1 as the inclusion of hybrid rye in the diet increased, but this was mostly driven by a very low average daily gain of pigs on the control diet. We did analyze mycotoxin concentrations for the cereal grains used in this experiment, and there were no alarming levels present in the corn or hybrid rye, so it is unclear to us why the control diet performed so poorly in this phase of the experiment. Nevertheless, average daily gain was not different in phase 2, 3, or overall. Average daily feed intake also increased in this experiment during phase 1, phase 3, and overall as the inclusion of hybrid rye in the diet increased. Thus, there was a reduction in gain to feed as more hybrid rye was included in the diets in phase 2, phase 3, and overall. Again, this reduction in gain to feed was likely due to the reduced metabolizable energy content of rye compared with corn. For phase 1, an increase in gain to feed was observed with greater amounts of hybrid rye in the diet, but this effect was driven by the exceptionally low average daily gain observed in phase 1 for the control group. Unlike in experiment 1, there were no differences observed for diarrhea incidence in this experiment. This conflicts with what was observed before, but it could be due to different pathogen loads or stressors associated with the 2 different weaning groups. Just like in experiment 1, we again observed an increase in blood urea nitrogen when more hybrid rye was fed. To conclude experiment 2, we tested inclusion rates of hybrid rye up to 24, 48, and 60% in phases 1, 2, and 3 respectively. With each of these inclusion rates, we observed no difference in fecal scores or incidence of diarrhea, and also no differences in average daily gain. With those high inclusion rates, we did, however, observe an increase in average daily feed intake with subsequent reduced gain to feed. But overall, our hypothesis was again largely supported that nursery pigs can be fed diets containing hybrid rye and perform similarly to pigs fed diets containing corn. Based on these two experiments, we recommend that you can feed up to 24% of hybrid rye in phase 1 diets, up to 48% hybrid rye in phase 2 diets, and up to 60% hybrid rye in phase 3 diets without jeopardizing average daily gain. We do suspect, however, that the reduced metabolizable energy in hybrid rye compared with corn will likely result in greater average daily feed intake and reduced gain to feed if diets are formulated with a straight substitution of corn for hybrid rye as they were here. This reduction in gain to feed could potentially be minimized if greater energy in the form of fat is supplemented to diets containing greater amounts of hybrid rye. This concludes my presentation, and I thank you for your attention. If you'd like to contact me, again, my name is Molly McGhee, and my email is located on the bottom left of the screen. You can also visit Dr. Stein's Monogastric Nutrition Laboratory website to learn about other projects going on in our lab. That website URL is www.nutrition.ansi.illinois.edu. Thank you again for listening.